Hello everybody, my name is Sam Hoodak. I'm a Mastercam Support Specialist here at OptiPro Systems in New York. I'm going to be covering the enhancements for Mastercam 2024 regarding lathe and mill-turn. I got a slew of things I'd like to cover here. I'm going to start with some B-axis contour enhancements for lathe. We got some mill-turn stuff as well, all good things. So first thing, like I said, I'd like to cover some variable depth of cut inside lathe rough. So this was added prior to 24, but it was capped at 20%. This year we're able to increase it to 100%. So if you haven't used this before, what this does is this takes your depth of cut and adds some variability to it by increasing or decreasing the cut depth at the start, and again going to the end there, either going to a percentage increase or a percentage decrease. So what this does is this changes where the tool is cutting along the insert. This should increase tool life and reduce the chance of chipping out along the insert. Next thing I'd like to cover is dynamic rough has gained the ability to use lead in and lead out on semi-finished passes. So it's just like the lead in and lead out you've seen in plenty of other tool paths, but now we have the control to take care of lead in and lead out for the semi-finished passes. So I'd like to show you guys how to do both those things I just mentioned. So what I've got here is a part. I'd like to rough this down using lathe rough and then hop in with a dynamic rough to finish the groove portion. So I'm going to hop into my lathe rough toolpath. I'm going to chain the top here to the top here, hit the green check. And for starters, what I'm going to do is I'm just going to set the depth of cut to 200 thousandths with no real change. Use lead in and lead out and use stock for outer boundary. I'm just going to turn off the rapid retract motion to see it a little better. Pretty standard pass. What I'd like to do is I'd like to introduce that variable cut depth. So what I'm able to do here is, let's just say we add 50% depth of cut. I hit the green check. What we're going to see is the first pass remains the same, but the next pass is going to start at a 50% larger depth. So we should see 300 thousandths start a cut here and go to 100%. So I go to 100 thousandths. On the next pass, we're going to see the opposite. It's going to start at 100 thousandths and it's going to end at 300 thousandths. Again, just to reiterate, what this does is this is going to change the edge of which the insert is cutting with, hopefully using more of the insert, hopefully reducing the chance of chip out. Next thing I like to cover here is dynamic rough. So I'm going to go roughly the same area. I'm going to start at the chamfer there, end at the chamfer here, and hit the green check. I want to make sure that I'm choosing a full radius tool. Only full rad and button tools are supported for lathe dynamic rough. I'm going to go to the dynamic rough settings, set my step over to, let's just say, 25%. We're going to go to 30% for toolpath radius. I'm going to turn on my semi-finish, and let's just for now turn off lead in and lead out. I'm going to hit the green check. It's going to take a minute here to think, and we're going to see a toolpath create. Once this generates, we're going to see that we have now violated the tool clearance boundary. I'm going to ignore this warning for now and hit the green check. What we're going to find is that if I go into the parameters here and I enable lead in and lead out, and I head over to the semi-finish lead in, tell it to go directly down or even tangent, I can do the same thing with the lead out and go directly off to the side. I'll just keep it like that. Hit the green check, and we should find that that error now goes away. And we do. So everything is all even keel in the world again, and we're able to continue on. So taking a look at the next thing, we got some mill-turn simulation enhancements. First things first is we got the ability to add move type, machining time, move length, and feed rate to the move list. Initially, this does not populate in there, so if you'll notice, I got this marked up in the top right side here, that little plus button. Inside Mill-turn move list, you're going to hit that plus, and you're now able to add those lists, or add those sections. Prior, we had just been limited to X, Y, Z coordinates and move ID. So now I got a couple more things there to look. Another thing that's been added is the ability to change the background color inside your Mill-turn simulation. This is separate than your main portion of Mastercam, so just a little bit more ability to change some features. And the last thing is now stop conditions have been added to incorporate tool orientation. So what does that really mean? Well, that just means if your left spindle should be rotating clockwise, but it's rotating counterclockwise, Mastercam is going to let you know. It's going to stop the machine, stop the simulation, so that you can go back and fix what's wrong and then be able to continue on your merry way with your new fixed simulation. Another new thing that was added was creating a new spindle origin for spindle move operations. So what this does is this gives you the ability to generate a new set of planes whose origin matches the new location that you select. It gives the ability to associate a new origin with the new position. This gives it so that you can add a G55, G56, G57, and have your move work off that position. B-axis contour enhancements. There's 3 of them this year. So the first one is the adjust stock button. This is going to look a little different than your traditional adjust stock in other toolpaths. This is going to show up with 3 little white dots on each start and end portion. You're able to snap to these different positions as like a quick way to move through your toolpath. So we can extend the cut, add a chamfer, remove the chamfer just by clicking on one of these 3 buttons. You can move it anywhere else, but the 3 buttons that show up, or the 3 white dots that show up, are easy snap locations. I'm going to show you guys this one here in a second. Another thing that got added is the ability to designate a cutting edge of an insert. So whatever tool you're using, you can actually select where you'd like to cut with that insert. This gives the ability to give a little bit more control to the B-axis contour, and this will actually adjust the toolpath to compensate for your selected geometry. Another thing, the final thing that got added to B-axis contour, is the ability to change the tool axis control option to modified. So prior to this, you were stuck with automatic and manual. Automatic was pretty much Mastercam deciding most of the toolpath motion with a little bit of room to tweak. The other option was creating geometry, creating toolpath vectors, and having the toolpath follow those vectors. Well, this is a little bit of a combination. So what you get to do is you're able to actually alter these green arrows, and I'm going to show you this here in a minute. You're actually able to alter these green arrows and change where the toolpath sits at this certain position. Nice quick way to make a very controlled toolpath. So let's talk about that here next. So I have another toolpath over here, another 2, both B-axis toolpaths. So looking at this, we got our first toolpath here. I'm going to hop into parameters, and we're going to take a look at adjusting stock. Right now we're getting a toolpath that kind of starts off into the material and ends up before the material ends. I'd like to make it so that I maybe start a chamfer down here and elongate the cut along the end. So if I go to the second last option down here at the bottom called stock, I can hit my adjust stock button. I'm able to grab my green dot and bring it down to this far white one at the end, and I can actually snap to it. I'm going to do the same thing with the red one here. The minute I click or hover over the red one, I'm going to see those 2 other white dots appear. Notice as I'm rotating, I'm seeing the orange area change. That is also indicating where my cut is going to end or start, depending upon which one I'm selecting. I'm going to hit enter, and I'm going to hit the green check and regenerate my toolpath. And what we're going to see here is what I set out to do is going to be completed. I'm going to start a chamfer here, or elongate my chamfer, and I'm going to elongate my cut here at the end. Looks great. Next thing I want to do is adjust the cutting edge of my insert. So one more option up, going advanced motion control. Where it says maximum insert depth, I can go down to manual, click on this icon here called edit depth, and we're going to see my tool populate, my insert and holder combined. I'm going to grab, again, my start or my end dot, and I can actually see where the insert's going to be cutting with. So what's going to happen is, when I do this, what's not highlighted is going to act like a holder, and it's going to make sure it avoids that cut. So if I have this pink area selected, it's going to avoid cutting with the top portion. What I'm going to do here is I'm going to slide this cut up, maybe this down here, and I'll hit enter and the green check, and we're going to see that the motion now fits that geometry. So again, it's going to prioritize cutting and prioritize avoiding the area that's not highlighted. If we play the toolpath, we're going to see that it stays in that area. Make sure that it doesn't cut that way. Looks good. Last thing I want to take a look at is this ID here. Now I can't see it, so I'm going to go to levels, and I'm going to go turn on, planes, and I'm going to turn on my section view. And this will make it so that I can see the inside of my part. If I go to my toolpath and I go to my parameters here, and I go to one more option up where it's basic motion control. Prior to 24, I had automatic and manual. Now we have this modified option where I can select modified and click my edit vectors. And what I'm going to see are 5 arrows populate. And if I hover over one and I click one down, if I rotate this arrow around, I can actually see my tool and my holder. I can actually change the position my cut starts or rotates to, and we're actually going to see here if I go too far in one of these directions, maybe on another spot. If I hit escape real quick and go to over here, I can actually see if I tilt too far that I actually create an area where my holder and insert collides with my cutting edge. So this is a nice quick way and a safe way to make toolpath motion altered in just a couple seconds. All right, here's another big one. Turret-mounted angled milling heads. This is now completely supported inside Mill-turn. So I've actually already helped a couple customers with this already. We've got maybe twin turret, twin spindle machines, or single turret, twin spindle. We've got an angled slot, or we've got a off-center bore we have to mill. Now inside Mill-turn, we can completely add solid models for angled milling heads, whether it's fixed angles or adjustable angles. This gives us the ability to create G68 style tool paths on a machine that otherwise couldn't handle them. So let's take a look at doing those right now. All right, so I've got this part in my sub spindle over here. What I've got is a pretty simple hole, and I just want to mill out that hole, mill out the counter bore. So setting this up is going to be pretty simple. Once we've added it to the component library, using it is a breeze. And for anybody that wants to do this, I'm going to have my email at the end. Feel free to shoot me an email. Whatever works, we can go through doing this on your machine as well. I'm going to go to milling. I'm going to hit the drop down, and let's go to our hole making toolpath. We'll keep this simple. Maybe I want to do let's do a helix bore. What I'm going to do is I'm going to go find my geometry, and I'm going to pick the solid wall of my geometry. For those that aren't used to doing this, this is the way we recommend. Notice picking the solid face shows solid face, and it also shows the corresponding diameter. This is going to be very helpful for multiple different reasons, and I'm going to go into those here in a second. I'm going to hit the green check. I'm going to go to my tool page. I'm going to go right-click, Create Tool. I'm going to go to Flat End Mill, and I'm going to make a 187.5 flat end mill. I'm going to hit Finish. Now, to enable the angled milling head, I have to go right-click, Get Angled Head. We're going to see this show up. Note that my tool 4 is the one that's using this, and I should have this loaded in already. I'm going to grab the upper indexable angled milling head, bring it to index position 4. I can hit the plus, and I can bring my tool in. So now if I go right-click, View Component in All Children, I should be able to see my angled milling head. We'll adjust the tool holder to make sure it fits in there. Doesn't quite look in place, but we'll be able to get that adjusted later. Hit Enter. Hit the green check, and I'm off to the races. So now what I can do is I can go to holder. If I really wanted to, I could go right-click, Edit Holder. I would change this to match my tool size if I were to do a quick fix. 187.5 for the top, 187.5 for the bottom, and I could go like 10 thousandths. Hit Finish, and it's going to look a little bit more normal. Change the tool projection to 2 inches, or whatever works, and now I can go to Setup. I'm going to have it set to plane rotation, derived from geometry, and that should make it so that the angled milling head aligns to this hole right here. I'm going to go to Cut Parameters, and everything else here is like a normal helix bore. So I'm going to go perpendicular entry. I'm going to go 0 on walls, 0 on floors. If I wanted to enable cutter comp, I could enable a cutter comp. Maybe I'll do a 30,000 rough pitch, and my finish will be a circle at the bottom. And I can make the step over finish at 10 thou. Tool axis control will remain the same. And heading to linking parameters, this is the important part of why we pick the solid wall. By clicking on calculate incrementals from holes, incremental values from holes and lines, I can set everything to where I want it. So if I set my top of stock to incremental 0, notice that my top of stock is where it should be. My depth is where it should be. My feed plane is 100 thou from the top of stock. My retract is 250 from the top of stock. And now I can turn on clearance and go 0.75 and set that also to incremental. And my values look good. Now, if you haven't seen this before, this is for 2024. All the hole making operations get these planes, these colored planes. Makes life a little bit easier to tell what's going on. So if I hit the green check, we get our tool path that looks pretty mint. So that looks great. So another thing that got added this year was Mill-turn coolant strategy editor. So we've always had Mill-turn coolant strategies, but consumers have not always had the ability to go edit those. What was added this year was the ability to add those strategies. Well, what's a strategy? A strategy is not necessarily an M code, but a slew of M codes or a certain operation using M codes in a particular matter. If you look at the right-hand side here, this is a coolant strategy, and these are coolant options. So it's saying when to enable and disable coolant strategies. You can now edit existing ones, delete existing ones, add new ones, without having to go contact your reseller to go add these options. To get there, you're going to go to Consumer, Output Settings, and then head over to this icon here under the coolant strategy. So the last thing I want to talk about here is some new lathe mill-turn or lathe simple machine environments and new mill-turn environments. What's the difference? Well, a lathe simple machine requires a seat of lathe and mill to run, while mill-turn requires only a seat of mill-turn. So these are some new machines that got added this year. Some Doosan Pumas, some Doosan Lynxes, some new Akumas, some Haas machines. And then for the mill-turn environments, we've got some Mazak Integrexes, some Hyper Quadrex, DMG Mori, Akumas, Emco Power Mills. So we've got a bunch, and this is already on top of our long list of mill-turn and simple machine environments. So only more power to the user going forward. So just to reiterate, guys, my name's Sam Hoodak. Again, I'm a Mastercam support specialist here at OptiPro. If you want to get a hold of me in particular, reach out to me at shoodak@optipro.com. Or if you're looking for our entire Mastercam department, it's mastercam@optipro.com. I hope to hear from you guys. It's a pleasure as always. You guys have a wonderful day. Good talking to you.